So this is from the Angular Kinematics and Acceleration worksheet, and it's question number 3 on the back of the worksheet. So this question reads, one of the largest scientific devices in the world is the particle accelerator at Fermilab in Batavia, Illinois. The accelerator consists of a giant ring or circle with a radius of 1 kilometer. Suppose a maintenance engineer drives around the accelerator starting at an angular speed of 5 times 10 to the power of negative 3 radians per second and accelerating at a constant rate until one trip is completed in 14 minutes. Okay, so let's start by drawing this out. Okay, so again, we've got a circular machine and we've got a man traveling around the machine and he completes one full trip. So what are the variables we know about this trip? So we know that the radius of the machine is 1 kilometer, which is equal to 1,000 meters. We know that he starts with an acceleration of 5 times 10 to the power of negative 3 radians per second, okay, which essentially is his initial speed. So we call that W at time 0, or W0. Okay, then we know that he is accelerating at a constant rate, but we don't know his acceleration, and that's what we're trying to find. And we do know that he has completed one entire trip. And we know that if he has completed one entire trip, okay, that actually tells us his displacement, or theta. Okay, and we know that that number is equal to 1 revolution around the circle, which we can then convert into radians using the conversion factor. 2 pi radians is equal to 1 revolution, okay, giving us a theta, or angular displacement, of 2 pi radians. Okay. We also know that the amount of time that he took to complete this is 14 minutes, which is again not in the correct units, so we need to convert minutes to seconds. We know that 60 seconds are in 1 minute, so 14 minutes is 840 seconds. Okay, so now we've got 4 variables: our radius, our initial speed, our total displacement, and our amount of time, and we are trying to find acceleration. So looking at your kinematics formula, the formula that contains all of these is theta is equal to the initial speed, which is W0 times time, plus 1/2 of the acceleration times time squared. Okay, it won't let me do the little squared sign, so just know that that means acceleration times time squared, right? We have theta, we have WO, we have time. The only thing that we don't have in this formula is acceleration, so we can change this formula around so that acceleration is what we are solving for. So the first thing that we've got is theta, okay, and from theta, or from both sides, we are going to subtract the initial speed times the time. Okay, that leaves us with 1/2 acceleration times time squared on the other side. Okay, now we can get rid of the half by multiplying this entire thing by 2. Okay, so we end up with 2 times, in brackets, theta minus speed initial times time, closing bracket. Okay, and that whole thing is equal to acceleration times time squared. So the last thing I have to do to isolate for acceleration is divide both sides by time squared. So we're dividing this by time, and I'll draw it in this time, to the power of 2, or time squared. Okay, if you go ahead and plug that into your calculator, you should get the answer 5.9 times 10 to the power of 6 radians per second squared.